Okay, a very good day to you. Today I'm going to present the summarized application using natural language processing by the work of my student Wilhelm and they together with you. Okay, Troy. Okay, in this information flooded era, ever-increasing article export from digital media that user can easily access from the internet. Okay? As the number of articles rise, it is hard to go through the entire related area manually within a short time of period. One of the solutions for this is actually using automatic summarizer. To create the automatic summarizer, we can use the natural language processing of NLP to process the textual data, extract useful information through the part of speech tagging and sentiment analysis. There are two types of automatic summarizer. One is extraction, another one is abstraction. The difference between these two is actually extraction. We extract the existing words from the articles, existing phrase. If the abstraction is involved, paraphrasing performs a new article, a new summary. Okay, extraction involves the first step, reprocessing, to remove the hyperlink, stop word, aberrations, and the noise and non-informative parts. Second step is tokenization. It's actually segmenting text into words. It is a process of replacing sensitive data with unique identification symbols. The third step is rank. Exactly, a score is calculated for each sentence based on the frequency count associated with the word contains. The ranking of the element in the graph is produced. After ranking, a graph is formed, and the most important elements are the ones that better describe the text. Let me show the first extractive summarizer, which is called as text summarizer by Sukri and Wagasa in 2019. Aims to generate a coherent and understandable summary using deep learning model. Their preprocessing step involves the document segmentation, which is actually segmenting document into paragraph. So paragraph segmentation is actually segmented paragraph into sentence. Third is lemmatization and stemming. Fourth, remove the stop words. Fifth is token text into verbs, noun, and adjective using the NLTK tool in Python. Okay, and then the extract this nice sentence feature. Nice sentence features. Form the sentence feature matrix. And the sentence feature is trained through the restricted Boltzmann machine model. Okay, at last, a refined and enhanced matrix will be generated, and the generated enhanced feature vector are used to generate score against each sentence, and lastly, summary is generated. The second extractive algorithm is based on Barrios et al. 2016, where they name it as Sigma Tag Rank. Okay, Sigma Tag Rank is actually based on the original text rank, which is shown here, where from multiple articles is combined into text, and the text is split into sentence. Okay, after that, vector representation word embedding will be found for each sentence. Okay, similarity between the sentence vector will be calculated and fed into the metric form. Okay, later on, a graph is converted from similarity matrix Okay, with the sentences as the vertices and similarity score as H or sentence rank. And at last, okay, a summary is generated. Okay, various at all actually they modify the original text rank by implementing the function be identified, cosine sim, and the longest common is subsequent LCS form the sigma tag rank. Okay, the third extractive algorithm is a variable online extractive algorithm called as SMMRY. Okay, what they did is actually they associated words with their grammatical counterparts, calculating the occurrence of each word in the text, assign each word a point depending on their popularity, split up the text into individual sentences, and rank sentences by the sum of their words point, and returning X of the most highly ranked sentence. The difference between these three algorithms, okay, the text summarizer uses deep learning, sigma tag rank machine learning, SMMRY. It is actually original text rank and is a variable online tool. Okay, we have the limitation for using the abstraction because there are limitations of hardware where we need the GPU, okay, or TPU, and we need a lot of data set to train for abstractions, okay, or abstractive algorithm. That's why, okay, the summarizer that we built is actually based on the extractive, the objective. So to develop the summarization apps using sigma tag rank, we compare three key algorithms just now. We choose this sigma tag rank because it gives the best F score and lowest means among SMMRY and text summarizer for 30 BBC article carried out by reference case 1. Later on, to test the performance of the developed app using the graph 2.02 kits using 3 articles, and then compare it with SMMRY and text summarizer 11. Okay, the methodology for this study is very simple. Okay, this involves the app development and the performance evaluations, and then we evaluate it using the graph 2. Where the rough N includes the rough 1, rough 2. Rough 1 is a unigram, rough 2 is a bigram, then rough L and rough S. And then, okay, rough K evaluate in terms of the recall, which is number of overlapping words divided by total word in reference summary. Reference summary is the mean. Okay, in this study, we asked a master student to summarize an article that we give to us, and the system summary is actually did by the summarizer. Okay, so the position is number of overlap words compared to total words in system summary. This is an F score. Okay. And then for rough N, they're actually measuring unigram by gram. For example, rough 1 and rough 2. Okay, for example, you have the reference summary. It's actually police killed the gunman. And the system algorithm 1 and 2. The output, okay, 1 here, police killed the gunman. Okay, for rough 1, it's actually measured the unigram. So you have police, correct? Kill is not the same because this is present tense past tense. So police is correct, the is correct, gunman is correct. So 3 out of 4 is correct. You get 0.75. For the system summary number 2, the gunman, police, they did not care for the sequence. So also 0.75. Okay, for graph 2 is actually by grammar. 2 word, police killed wrong. So killed the also wrong. Only correct the gunman. So it's only okay. Actually, we got how many sequence? Police killed is 1, kill the is 2, the gunman. So they got 3 combinations of bigram. So they got 1 out of 3 is correct. So the system summary 2 also the gunman. Gunman killed. Killed police. No, so only the gunman. So it's similar. 1/3. Rough L is actually summary sentence will be treated as a sequence of words, more focused in words position or sequence if compared with rough N. Example, for rough L, if police kill the gunman, rough L is by unigram, police the gunman. So it's still 3/4. System summary 2. The correct gunman correct. So only 2. Because it means rough 1 compared to rough L because sequence is important. So it's only the and gunman correct. For later on the rough SU, measure the overlap of skip diagram between a candidate translation and a set of reference translation. Example, rough SU2. Diagram. So the correct one is police kill. But you can skip the word. We have police kill the gunman. That is like the rough 2. Police kill the gunman. In the sequence 1 without skip the word that is a rough 2. For the rough SU2 we have police the. And then kill gunman. Jump 1, police the. Kill gunman. And then what else? Kill the. Police kill, police the, police gunman, and skip 2 also. Not only skip 1. Mean the rough 2 is actually police kill the gunman. The rough SU2 you may skip 1 word, police the, kill gunman. Or police gunman. So total 1, 2, 3, 4, 5, 6. And then you compare with the system summary. Police kill, but kill is wrong because it's not the past tense. So we have so the correct police gunman, the gunman 3 out of 6. The second system summary, the gunman, the police, so we have only the gunman, the kill, we don't have the police, we don't have, kill police don't have, gunman police don't have, so the only correct one is 1/6. So we have considered the rough 1, rough 2, rough L, and rough SU4 was selected. For evaluate sentence, it has many different situations. Police kill the gunman versus the gunman police kill. And then for the result and discussion, this is our automatic summarizer view. This is the main page. Consists of the using file and plain text button. Once the user click the using file button, the right figure will be pop up. Let user choose the file and then can click the upload. Once they choose file button is click, the file directory is open for user to choose the text file. If not the text file was selected, then your error message will be popped up. If the plain text button if the main figure is chosen. Then the text box is prepared for user to paste the text to be summarized here. And then user can click the upload. Okay. And then the upload button will connect the upload functions for transferring the text file to the server, which consists of the extractive algorithm to undergo summarization. Later on, user can provide the summary ratio in this figure. Once the summary ratio is provided, the summary is generated. This result show the rough 1 and rough 2 for the Sigma tag rank, which was used to build this automatic summarizer. Shows the highest mean F score compared to the other two algorithms for rough 1 and rough 2. The average F score, because there are 3 articles, that's why average it. For rough L and rough SU4 also, Sigma tag rank show the highest mean F score for both rough L and rough SU4 compared to text summarizer. This is using deep learning. This is a variable extractive summarizer online. This is based on the modify the original tag rank method. The conclusion: an extractive summary apps was built using Sigma tag rank, XAMPP, and PHP code. The performance of the apps was compared with the other two extractive algorithms, which are SMMRY and text summarizer, using 3 linguistic articles. The reference summary was summarized by a student who is currently studying a master's degree in the English language. The performance was evaluated using the rough toolkits. The mean F score for rough 1, 2, L, and SU show the apps give the best performance. These are the references used. Okay, and thank you for the run. Thank you for attention.